Hello everyone, let us continue with our lesson. I hope you're doing well. Remember to stay healthy and put on your mask even though you are at home. Okay? So now yesterday we already finished talking about the preparation of preparation of aldehyde and ketone. If you remember, for example, for getting aldehyde, do you remember the method? We are going to oxidize the primary alcohol. Okay, together, remember, start your experiment setup with distillation. Then you will get aldehyde. For example, we are doing a revision now, okay, before we go further. If you have ethanol, then you oxidize it. With distillation, you get ethanol. Okay, can you see this is primary alcohol? Okay, however, if you want to get ketone, you need a secondary alcohol. So when you oxidize it, it becomes a ketone. Okay, for example, if you have something like that, okay, this is propane 2O, okay, and then if you oxidize it, this group will remain, and then you add a double bond here and cause out these two, okay, then it will become propanone. Okay, now this is what we learned yesterday. Any question? Now if no question, then we will go to reactions of carbonyl compound. Reactions of carbonyl compound. The first reaction I want to talk about is the reduction of carbonyl compound. Now, for aldehyde and ketone, basically it's the reverse of oxidation. This is oxidation, right? If you use reducing agent, you can turn the aldehyde back all the way back to primary alcohol, and if same as ketone, if you use reducing agent, okay, then you can turn it back to secondary alcohol. Okay, now remember reduction, when you write chemical equation, as I told you, you add hydrogen atom. Okay, because by definition the addition of oxygen is oxidation and the addition of hydrogen is reduction. Okay, so there are two reducing agent I have to introduce to you. This is one that we already learned it in the chapter of alcohol. The first one is lithium, LiAlH4 in dry ether. As I told you, it reacts violently in water, so we need to use dry ether as the solvent. Normally, that is the condition, okay, and that is the reagent, okay. It happens at room temperature. Okay, now this is a more powerful one. I will let you know the difference between the first one and the second one. The second one is NaBH4, okay, in sodium hydroxide solution, and you need to warm it a bit, okay. These two can help you to reduce both ketone and aldehyde all the way back to their corresponding alcohol. And this one is called sodium. The name is very similar to lithium one, tetrahydroborate. Okay, and this one, do you remember its name? Lithium hydroaluminate. Okay, now then you may wonder, why do we have two reducing agents? What are the differences between them? Now I will compare them with you so that you know which one you're going to use in different situation. Okay, now first, this one is much stronger. Basically, both of them can reduce the aldehyde and ketone into the corresponding alcohol, but this one can also reduce carboxylic acid, as what we learned in the last chapter. Now, for example, if you have aldehyde, if you use this one, then of course, definitely it can go back to primary alcohol. Same as this one, if you use this one, it can also go back to primary alcohol. Okay, now we will balance them later. Okay, however, if you have carboxylic acid and you want it to go back to primary alcohol, you have to use lithium aluminum hydride. Lithium tetrahydroaluminate. Okay, in dry ether, in order to make this happen. But the NaBH4 is not strong enough to reduce carboxylic acid. If you use NaBH4, then you will have no reaction. Do you understand what I'm saying? So this is the major difference. That is the LiBH4 and LiAlH4 can help you to reduce the aldehyde, the ketone, and the carboxylic acid. But NaBH4 can only be used to reduce aldehyde and ketone. It doesn't react with carboxylic acid. Are you okay with this? Now then, let's just go back to the handout, okay? Because I want to fill in some blanks with you first, okay? Now, turn to page 1. Okay? So general representation of a carbonyl compound. We all know that, right? So this one, aldehyde is C double bond OH, and ketone is C double bond O, with the left and right hand side bonded with an alkyl group. Okay, aldehyde can be formed from oxidation, that's what we learned yesterday, of primary alcohol. Okay, and remember to use distillation if you want to isolate the aldehyde, because if you don't, it will go all the way to carboxylic acid. Distillation, I already drew this diagram to you yesterday, so try to refer to what the previous video. Ketone can be formed by the oxidation of a secondary alcohol. Okay, oxidation of secondary alcohol. Okay, then this is what we have done yesterday. We can check the answer together. Propinol structures. I use the skeletal formula 1, 2, 3. Propinol. Okay, remember when you draw skeletal formula, do not write any hydrogen atom. Okay, unless it is a OH group. Okay, or COOH group. Okay, pentane 2 long. 1, 2, 3, 4, 5. 2. 1, 2, 3, 4, 5. Okay. Oh, methanol, as I told you, we just have to do this. Okay. Okay, convert already. I bet if you know how to write the skeletal formula, you should be able to write the structural formula or display formula, right? Oh, now this is what I just told you. Okay. If you have to reduce aldehyde and ketone, now remember, alcohol through oxidation to become aldehyde or ketone, and then reduction to go back. Okay, so if you reduce an aldehyde, it goes all the way to primary alcohol, because the aldehyde is formed from the oxidation of primary alcohol. If you want to get secondary alcohol, you have to reduce a ketone. Okay, and here are the two very important reducing agent you have to bear in mind right now. One is LiAlH4 in dry ether. If the question asks you to name it, it is lithium tetrahydro. Not enough space. Aluminate. If you have enough space, put them together. And then the other one is NaBH4 in alkali solution. Normally sodium hydroxide solution, dilute. Okay, so this one is sodium tetrahydroborate. Okay, 好， Now, warming the aldehyde or ketone with an aqueous solution is talking about this one, okay? Talking about this one. You need warm, okay? So, the answer is this one, sodium tetrahydroborate, okay? Or you can use adding LiAlH4, but you have to use dry ether because as I told you, LiAlH4, if you remember, it reacts violently with water, okay? So the organic solvent has to be dry because I already put down the answer because lithium aluminum hydride reacts violently with water. Now it's called lithium tetrahydroaluminate in your syllabus, but in Hong Kong DSE it's called lithium aluminum hydride. So I want to stick to your syllabus. I want you to stick to your syllabus, called it lithium tetrahydroaluminate. Okay? 好，嗱，and then when you see page 3, there is a reaction, nucleophilic addition with HCN. I will go back to this reaction in the next video because it's already 11 minutes. I have to stop right now. Bye.